Hello beautiful people, this is Luke. So this is something a little bit new. I don't do videos a lot for this project, but what's going to happen today is I thought I would actually record a video of me putting together one of my circuits, just so you guys can sort of see my building process. So what I'm going to be doing is I'm going to be making a filter using my new op amp, which is the circuit I got over the weekend. I think I wrote a journal about it. If I didn't, then I'm remembering things wrong, but I'm pretty sure I did. So you can see right here, this is what my oscillator circuit is going to be, and then with this, I'm going to build my filter. Now, I took out some of these jumper wires because there's a bunch of them, and I didn't want the camera to get cluttered, and I'll add them back in at the end. So first what I'm going to do, so let me explain. I have a couple things up on my screen right now. I'll put them in my journal when I type this up. First, I have the circuit diagram of what I'm building. This is sort of like instructions on how to put it together. And then the other thing I have is what's called a pin layout. And see how there's 8 pins on this op amp? There's 4 on this side, 4 on this side. Each of them has a specific function. And in order to not get confused about which does which, you have a sort of map that tells you which one does what. For example, this one right here is the ground, so that would be plugged into ground. And then the one up here is that one? No, this one. This one is power. This one is output. And output is actually very useful. We'll be using it. So when I usually do this, I start reading stuff left to right because that's easy. So first, I want to take the output of the synthesizer because we want to filter the output. And so that, according to the diagram, is going to be going into the negative input of the op amp, which is pin number 2. So that's going to go right there. Let's see what happens next. So also, branching off from there, we're going to have this branching off into what looks like a resistor and a capacitor. All right. So, and I believe I'm... Ooh, actually, okay, I actually did forget something. So I have to do resistors going in to this. So what I'm going to do is I'm going to move this over here. Yeah, let's go over here. And it says I need 1.5k ohms. Now I don't have a 1.5k resistor, so I have a 100 and a 500. And what happens if you put resistors in what's called series, so just one going after the other, then you just add together the resistance values. So that's pretty convenient. So I'm gonna put these two together. Perfect. They're a little bit shaky because I've been reusing them a couple times. So then this is going to go into the negative. And this one's negative. No, it's pin number 3. Want to go? Nope, it is pin number 2. I lied. All right. Yeah, and see, this is why I didn't want to include the jumpers because they kind of get in the way of the camera. All right. So next step is we have to have resistor and capacitor in what's called parallel. So that means that they're just kind of like, they eventually reconnect at the end, but they're not in series together like these resistors are. So they both end up going parallel with the output. So I'm going to do, so I'll take my capacitor. Let me show it to you guys. Here's my capacitor. This is a 103 capacitor, meaning it has a capacitance value of 0.01 farads. Which you don't really need to know, but it actually is important for calculating what the cutoff frequency will be. So what I'm going to do is this needs to go from here, and it needs to end at the output. Output is pin number 6, so it's going to bend kind of over the chip and go right in there. Perfect. All right, and then I also need a resistor. Now this resistor, R2, it's labeled in the diagram, is actually what's going to be controlling the cutoff frequency. So what I'm going to do is I'm going to grab a potentiometer, which, if you guys remember from my journal, is just a resistor, but its value can change. Here it is. It's like this little dial. All right. So just plug in 2 jumper wires. I'm going to use 2 green ones, so I remember that these 2 are performing the same function. So this one is going to go on the right, over here, go on the left. I've gotten used to using these potentiometers. The pins are 1 hole apart on my breadboard. Let me shift it over a little bit so you guys can see. I'm just going to stick that right in there. So this will be the resistance control for our filter. And actually, I did this wrong. I need to have this end up going here to the output. All right, cool. And so that looks like it's the top part, that big square, that's done. So now the next part is it looks like the positive input of the op amp is connected to ground. So let me grab a wire. I'm going to use this black one. And the positive input is pin number 3, so that's going to go right here. And that's going to connect to what I call the ground bus, which is basically this whole row of pins at the bottom are all going to be connected to ground when I connect the battery. And so that looks like it's it, actually. This is a pretty simple circuit. Now what I have to do is actually wire up power and ground, because as I said, I disconnected those things. So let's get some more cables. So first, power for the oscillator. The top left pin is the power pin. And for the oscillator, the bottom right pin is the ground pin. So I'll just plug those in. All right, there you go. I know it gets a little bit obscured once you get more and more jumper wires. Now the op amp isn't as easy. It's not top left and bottom right. So it looks like positive power is pin number 7. So that's going to be right up here. And by the way breadboards work is each vertical row is all connected. So when I have this pin here, the whole row above it is connected to that pin. So that's why I can put it in that topmost hole. And it looks like negative is the bottom right, pin number 4. So that'll go right in there. Let's connect that to ground. All right. And the last thing is I took apart the oscillator. I just have to reconnect to the potentiometer. So I have, that's the oscillator resistor input. I know I'm throwing around a bunch of words right now, but trust me. So, all right. So that should be everything connected. Now what I'm going to need to do is also, I need to control the output. And I need one more jumper wire. Do I have one more jumper wire lying around my filthy home? It's not actually filthy, I'm joking. I do. One more. So then the output of this also has to go out to the rest of the circuit where it can be amplified by the volume control and then sent to the speakers. So let's take a whole look at this. So it's a big mess of wires and I gotta like sift through the jungle, but there it is. That's the whole circuit. So let's take a look and see. I hope I'm holding this the right way. God, I hope I am. So now what I have to do is I have to connect it back to my speaker. So let me fish around underneath my desk. You can see my Pokemon screensaver. So here we go, I've got this. Let me switch hands. That's gonna plug right into here. Right into the power jack. Not power jack, the headphone jack. So then this is my power supply. Red cable is power and white cable is ground. So, in theory, we connect these and it makes a sound. In theory, we connect these and it makes a sound. However, sometimes theory isn't what gets us anywhere. Let's see. If I turn any of the knobs, does anything happen? Nope. Do I have the filter turned all the way up, so that's not working? Let's turn volume all the way up so I'm sure I'm not like crazy. Turn the filter up and down. Nope. So this is the editing process. So I gotta figure out what's going on and why is it not working. Let's take a look. Let's make sure, first thing to do is to make sure everything is powered properly. So I have Power going into... Actually, no, the first thing is to disconnect the leads, because we don't know why it's not working. So disconnect power, because things can blow up if there's power in the wrong places. So let's look. So we have ground going to the right spot on the op amp. We have power going to the right spot on the op amp. I'm just doing a little look over. That purple cable in the top left is powering the Schmitt trigger. Bottom right power, providing ground to the Schmitt trigger. All right, let's make sure my oscillator circuit is okay. Looks good. So let's see if my resistors are in series properly. Does look like they are. Now hold on, let me see if I just take out this one. Put that there. So this is going to pin number 2, which is the negative input, which is where this is supposed to go, so that's good. And they're both in parallel. Let's see if powering it now. Maybe that was the issue. I don't know. We're not sure what the issue is. Nothing's coming out of my speakers. Let's see what happens if I just put this output. There we go. So what I did is I took this is outputting from the op amp and was going into the volume circuit, and that once I put it directly into the speaker, it works. So let's just do that for a bit. And let's see if the filter actually works. Oh, have to make sure I don't drop all the parts. Okay, volume. Oh, I turned off the volume control. Pitch control works. Let's see if the filter works. That is not what a filter is supposed to sound like. So that's cool.